Righto guys, we're back again looking at machining up the stays with this 2205 Duplex stainless steel. So I've done a little bit of research and I've rung around a few shops that actually work with this stuff and got a bit of a hint. So it's important to keep the speed slow, feed rates up. It's important not to let the tool dwell or rub, because as soon as that happens, this stuff work hardens almost immediately. So when I'm drilling through for holes to tap, I've got to make sure that I keep that flowing and don't stop. I can peck, but to clear the flutes, but I've got to come in and start to cut straight away. I can't allow that drill to rub and cause those hard spots. So I've got a number of these to make up. We're going to start off with number 18, which is 8 of. So these are the stays for the side of the firebox. So in any pressure vessel, which this is, where you have flat surfaces that are impinged by the pressure, you need to support those, otherwise they're going to blow out or belly out. So we put stays into those flat faces, particularly on a locomotive style boiler, to prevent that from happening. And there's a number of formulas that are used to work out the number of the stays and the pattern that they need to be in. Alright, so we've made a bit of a start on this at the moment. So as I said, we're running this fairly slow with a fairly high feed rate per rev, so we'll keep at it. So I've just backed this off very, very slightly. I've got to come down to 12 mil from 12.7 or ½ inch. And I'm using the Roco high pressure coil, which seems to be doing a pretty good job. So I'm just taking a skin pass on this to start with, and we'll see how it comes up. I'm also interested to see what tape was like on my tailstock. Right, so we're running down this cut at the moment. I've had to up the feed rate a little bit higher, and I'm starting to get some better results out of that. Right, let's see, we came up on OD. 0.01 over. 0.01 over. So about a tenth of a thou. So I'm going to leave it at that. That's perfect. As I said, these are only stays, and I'll be boring the holes into the firebox out of wrapper to size, and then the inner firebox wrapper gets tapped 1/8 BSP parallel to screw these into. Alright, I'll continue on. I'll get the rest of this stock down so we've got this down to size, then we can start looking at machining up some parts. Alright guys, so I've machined these little stay slugs, and I've cut them off with around about 1 millimetre to spare in length. And at the end of the bar, this is all I had left. So can't stuff these up, there's no more stock left. What I've done with the threads is I've made up a little trial mandrel, and I've tapped out a nut just to which is going to mimic the size, or will be the size, in the inner firebox when we thread these stays in. So I don't want this to be a tight fit, because it's the back welding on this that actually does the holding and the sealing. So the idea is every one of these I'm going to machine down to the threading diameter. Then I'll set them up, and I'll machine the undercut that you can just see in there, hopefully, for the thread run out. Then we'll set up and we'll cut each thread. So it's going to be step by step rather than all the operations being finished in one go. More step by step, and I can set my 0 points up very easily. And that's our final size in 2 cuts. So we're 0.01 up on our normal size, so I'm happy with that. Alright, I'll continue off and I'll do the rest of these diameters on all the stays, and then we'll come back when we're going to undercut and get ready to cut the threads. So what I'm finding is that if I get the handle in the right position for the cross slide, if I continually feed into my depth, I don't have any issues at all. So this is cutting quite nicely. As I said, once you dwell and let it stop, you can feel the fact that it's work hard, and it takes a bit of pressure to get that cut going again. So continuous, easy feed in without stopping is the way to go with this Duplex stainless. You know, these undercuts are working out really well on the parting off blade. I've actually thinned that parting off blade right down to about 1 millimetre is what the width is. Okay, the drawing calls for a 0.9 mil 45 degree chamfer on this edge, so I've just taken my threading tool, my carbide insert bit, and I've rotated that around till I've reached my 45 degrees, and we're going to plunge in. Now I've got to be very careful with this because we're widening out that cut, and if it does rub, it will work harden instantaneously, so we've got to make sure we keep the cut pretty constant on this. And there we go. I've done a couple of these already, and I've just done one where I did dwell very quickly, and you can really feel it having to work hard to overcome that hard face before it starts cutting again. So key is keep the feed rate fairly constant and reasonably hard too. Righto guys, we're cutting the threads now, and I'm going to single point cut these. I think if I used a die, I'm probably going to wear that out fairly quickly, and I can do these in 3 cuts, with the 4th cut being a spring pass, and it does cut quite well, provided we keep that depth up and we don't dwell. Because I have a metric lathe and I've set up for the Imperial, I can't take it out of engagement, so I run down, retract, and then reverse the machine, come back into the new depth and recut again. And that's it. We've got a nice little flat on the very tip of those threads, so I'm really happy with that. I've got a lot of rubbish in the threads, but that's going to be fine. It's going to feed on. It's got oil everywhere at the moment. It's hard to slip it on. So I'm happy with that. All right, we'll continue on with the rest of these, and then we'll flip them over and we'll do the final machining operation, which is machining a tiny little spigot on the end so that you can get onto that with a pair of pliers to screw these in. Alright guys, I've got to make up a couple of bushes out of this Duplex stainless, and I've got to tap a 1/4 inch 40 ME thread into this. So I'm drilling this out at 732. I've sharpened this up and I've honed the end of this, and you might remember the last time I tried cutting with or drilling, I just burnt the drills out like crazy. So I'm running this much slower. I'm running this at around about 100 RPM at the moment, which is probably about 5 times slower than what you would normally run, but it's working quite well. Lewis. What I'm going to do now is I'm going to part this off because I want to put this open-ended back into the collet to tap that hole out, and we'll see how we go. All right, let's see how we go off with parting. I'm just going to be hand feeding this. Alright, that parted off quite well. When you're re-gripping on that cross slide handle, you need to back it off, get your hand into the position again and feed it in, and once again don't allow that tool to rub in any way. Get the cut going as soon as you possibly can. Righto guys, I'm into tapping this now, and this is horrible stuff to feel. So you can feel it cutting well, but what happens is it tends to build up on the cutting edge, and to try and back it off it feels very gummy, and this is where you're going to snap the tap. Plenty of cutting fluid is really the key to this. I've got this Rocol high pressure cutting oil, and it seems to be working quite well. I have opened this up very, very slightly using my number drills. But these ME threads are so fine. They're really, really hard to tap with in this stuff. Alright, I'll leave you guys there so I can focus on not breaking another tap. And we'll see how we go. We'll bring you back when we're done. Alright, all tapped through successfully. I'm just going to put a little tiny chamfer on this now. I'm very relieved now that that's finished. I do need to cut a profile onto this in the milling machine to be able to profile around the boiler barrel, so we'll set that up very soon. Alright guys, on these two bushes we need to put a profile in here to match the ID of the boiler tube, but we're not going to profile these, we're just going to cut these straight across. It's around about 0.2 of a mil. The larger bush we're going to do the same thing again. It's around about 0.5 mil. And look, that will burn out when we start to TIG that into place. So profile is a lot of extra work for no real benefit. So I'm just going to cut them across. If I do a point-to-point line across here, it works out at 25 degrees. And that's what I've got set up here on the collet at the moment. So I've tilted my table to 25 degrees, just with my little Wixby. And I've marked out the low point, and the high point is just touching up off the edge there. So we'll set that up and we'll mill that across, and then that bush is completed. I might just show you a quick little setup we're doing here at the moment. I just need to square up the ends of the barrel for Andy, so that he's got reference points that he can start setting up a lot of his plate work to. So I've got the tube plate at the smoke box end jammed up inside here. It's quite tight inside here with a clamp over the top. We've got a clamp at the back as well. And all I'm going to be doing is with the ML is just traversing backwards and forwards until we get that face nicely squared up. We've done a lot of machining on a lot of other stuff on this. A lot of it's repetition stuff, so there are more stays to be done. There are some more bushes to be done. So no point showing all that. It's much the same. But I thought I'd just quickly show you this little setup and just how this is working. And that's it. We're done. Yeah, that's beautiful. Very happy with that. Now, if I had a bigger lathe, I probably would have done this in the lathe. Just machined a small register here and set that up on a steady and gave that a lick. But I haven't got a steady big enough to fit this, so hence the reason we're doing it in the milling machine. So, but it's worked out quite well. We've got a nice flat face now. That's at 90 degrees to the center line of the barrel. I'll flip it around and give it a lick on the other side, and it just gets everything nicely squared up so that he's got some reference points to work from. All right, guys, we'll see you soon. All right, guys, we've faced off the front face. I need to face off the rear face and take that back to length. So the overall length of this boiler is 352. So I need to take around about 2.5 mil off this face and back. And then we've got some boring that we need to do a little bit further up here to be able to fit some of those bushes that we've made up that need to be welded into place. All right, we'll get that underway. Just a note too, I've put some extended studs underneath here just to take up the load of the finger so that we don't deform the barrel. And obviously up the other end there we've got the front shoe plate supporting that. All right, let's get into it. Alright guys, we've got this off the length now, so that's at 352 long. What I'm going to do is we'll break the set up, we'll rotate it around 180 degrees, and we'll set some center points up and do our offsets to start machining in some of our holes to allow our bushes to be welded in. So yeah, we'll get that turned around now and we'll get that set up for that next operation. Right guys, I've got to put a hole into the boiler just on the other side here, but it's got to be 38 millimeters off center. So it's going to be cutting in on a shell at this point here, which is going to make it very, very awkward for me to try and measure. This is the bush that's got to go in. It's got to sit in there. So what we're going to do first of all is we're going to set up the boring head to suit a dummy hole, and that will be set. Then I can do the operations on here, put the boring head in, bore through, knowing that this diameter 20 bush is going to fit comfortably. So this is just a quick picture of where that bush has got to go. As I said, 38 millimeters offset from the center line. So as you can see, it's on a fair bit of the radius there. So we're not going to be able to measure that easily, and it's going to be hard to try and just keep creeping up on it to get a good fit. So we'll do a dummy run first. So I've just drilled this through with an 8.5 mil drill first. We're going to go in with a 3/4 cutter, 19 millimeters basically. Then we need to take it out 1 millimeter out to the 20 mil diameter. So we'll just quickly do this. The reason I put the drill through first, this isn't a center cutter, so I need to relieve that center. Right, that's more than deep enough. We'll set up the boring head next, and we'll get that set for the 20 mil diameter, ready for the cut into the boiler. Alright, I'm happy with that. That's just going in. I'll go another 0.05, just give it a bit more clearance when we're putting it into the boiler. Alright, we'll get our datum set up in the boiler and we'll get our position set, and we'll start the operation to get the hole put into that. Alright, we've got our offsets set up, we've locked the tables. So we're going to come down now and just spot face that. I'm using high speed steel. Let's see how we go. The reason I like the high speed steel is it's very easy for me to sharpen these up once they're blunted. I don't have diamond wheels at the moment. I'm on a to-do list to be able to do carbide, so I'll have a go at this, and very, very slowly. Well, I won't be grinding that one up again. That's been totally shattered trying to come through. But we can use that for bits of stock, making up other bits and pieces. Anyway, it's through. We'll set up with a 3/4 now and we'll come through with that. Just love machining this stuff. Alright, let's have a go with the big car. Okay, I'm just going to pull the camera out of the way because it's making it very, very hard to run the hand wheel, and my hand's cramping up a bit, so we'll come back when we're almost through. Well, I don't mind saying that was probably one of the most intense machining operations I've ever done. Just taking it very, very, very slow with this stuff. As I said, I had to be very careful not to dwell the cutter because it would work harden almost straight away. I've just left the tiniest little pip inside there. I'm not going to break through. That's where I had the issue the other time with the 3/8 slot drill. So we'll clean that out with a single point carbide bit on the boring head. Alright, very relieved. I'm going to go inside, have a cuppa, settle my nerves, and we'll come back out and we'll single point bore that. Alright guys, we'll see you in a tick. Alright guys, we're just single point cutting this now. I've already done it through once just to get a sizing. And we'll bring it out to size now, so I've got a few more of these to do. This single point cutting is so much more comfortable. Alright, I'll bring you guys back when we're doing our final cut, and we'll see how our fit up is. Alright, final cut. Alright, let's try the bush in there and we'll see if it fits. Alright. It's got to go that way, isn't it? There we go. Oh, it's a nice fit. Just presses in beautifully with your fingers. Alright, I'll call that a winner. Alright, I think that's the last of it for the machine. I do have one more long stay that I need to make up, but I'll do that off camera. Pretty much the same as the short stays we did. And we'll get this back to Andy and he can start ticking everything up. Alright guys, we'll see you next time.